Hello everybody, how are you? Happy Saturday night. This is live from Pittsburgh, Pennsylvania, where we're going to be talking about mathematics. Let the maths begin! Indeed. We do this every single weekend, and what the purpose of this 45-minute session is to discuss maybe an interesting mathematical problem that I came across recently, and maybe to talk about how to solve that problem. It's also going to have something interesting for parents or coaches who might be watching, because during the discussion of the problem, while students are thinking about it, I'll also make some comments about why I chose this question, which can be useful if you're trying to pick what questions to bring to your students. Now, other things that we'll do in this, I usually then open up for free Q&A, a free-ranging question and answer for the last approximately half hour of this live stream. And that's one of the most fun parts. As some of you know, if you attend my daily Ask Math Anything shows, I really enjoy answering questions that come from the crowd. The ones on the weekdays are focused on particular math questions. On the weekends, like this particular Saturday, we focus on questions that are more broad and general, things about how to learn math or what to use math for, or these general questions. We'll do that in the half an hour towards the end. Oh, I see some people also enjoy commenting on my shirt. That's in some sense how I know who's been here before. Yes, indeed, I reached into my closet today and I pulled out a shirt that had a year on it. This is from the International Math Olympiad in 2012, when I was bringing the United States team to compete. All right, well, I think we should go ahead and get started. I have a question that I want to share with you today. And this question is one that the people who watch my daily show already caught a glimpse of. In fact, this is the question that we would have talked about if we had extra time on Friday. I guess that was yesterday. And that question was from the Mustang Math Tournament. The Mustang Math Tournament was organized by students, and it had lots of really intriguing questions in it. And since there was one last question on that slide, I was quite curious what the answer was, so we had to do it. Is everyone ready? This is quite a puzzle. See if you can try to figure out how to do this problem. So I think this was inspired by some current events, such as the coronavirus, which is going on right now. So this is a problem where you're trying to figure out what those different letters are inside this puzzle. And this particular puzzle was not written by me. It was written by some very, very, very interesting high school students who had lots of great ideas. Now this problem here is one which is from Mustang Math Tournament, and it happens to be where in this following addition problem, each of these unique letters is represented by a different digit. So in particular, the digit for the S is different from the digit for the G. And now it happens to be that this is a legitimate addition problem. How can you figure out what these letters actually are? That's the problem. You guys will have a few minutes to think about this. Few minutes meaning maybe about 3 minutes, while I talk about the mentality of this for any of the coaches or parents who might be watching. If this is the first time that you've seen one of my shows like this, you may be wondering why I don't just tell the answer. Well, the reason is because the way that we can try to learn is by trying. And the best way to actually try is to try for a while and then maybe have a hint. Actually, that's my preferred teaching style. My preferred teaching style is where we have a problem and you fight with it for a while. And after a minute, a hint appears. And after another minute, then a second hint appears. And after you have all of these hints, hopefully, you might even be able to see a way to try to solve the problem. I see people are saying I should turn up the mic. One moment, please. What do we have here? Oh, this mic seems to already be pretty high. I think what I'll do is I'll turn up the mic here. So I have two different controls for the mic. Is this a little bit better, everybody? I'm a little bit curious. Is this better? Well, we'll see it from the chat. Meanwhile, as I said, the best way to learn is with hints. And so if you think about this for a while, I think the first hint, we have actually already seen some people in the chat mentioning something about this hint, which says, what does the leftmost digit tell you about R and C? Okay, right, we're going to let people keep thinking about this. And I'll continue to make some comments to parents and coaches of, how I came about choosing to highlight this question. It was because when I looked at this question, at first I thought, all you can do is trial and error. There's no information. So how could this even be interesting? It's so boring. I hate doing questions that are just trial and error. But actually, that first hint said that the R and C must have had a carry because all of the letters are different numbers. And to parents and coaches, when you're choosing problems, I strongly recommend never choosing a problem that is pure busy work. Don't choose problems that have just like trial and error for the sake of trial and error. It's best to have questions if there are some neat tricks inside. And that brings the second hint. You see, I don't want to just go and trial and error everything else, but look, there's the IRO in a column, and there's an IVO in a column. What does that tell you about R and V? I wonder if people have any ideas about this. And this is something which is trying to help, by providing these hints, I'm hoping to help people be able to play along with this question too. And I love how people are commenting in the chat. Actually, another comment to parents and coaches. To me, I had a lot of fun learning math because it was social. And by being able to be with other people who are all thinking about the same problem and sharing ideas, it was pretty interesting. For example, when people share ideas, you can even start to debate, and you can try to see whether the ideas might be right or wrong or good or bad. And we did already see an idea in the chat. Maybe R and V are the same, but they're not allowed to be. And if they're not allowed to be, how can we try to do this problem? All right, I think that takes us to the actual problem. So let's give this a go. I'll switch to my blackboard over here. And you know, maybe some people have already gotten the chance to think about this, and people are noticing all kinds of different patterns in these numbers. That's what made this question fun for me. At first, I actually thought, these people who organized the contest, what a terrible idea. What kind of question is this? And I didn't even want to do it until I thought about it for a while, and I saw it was beautiful. So it's like this. This is also easy to remember what the letters are, because unfortunately, it is a rising virus. We'll be writing this a few times. Whenever I look at a problem, before I do any guess and check and trial and error, I first want to get an idea of what things I know for sure. And I already saw that there was some very good observation in the chat that because the R is above C and because all the letters are different, it has to be that there's a carry, right? It has to be that there was some little carry up here. And so we know that C is one more than R. So now we know a useful piece of information. It's like R, and then plus 1 is equal to C. But do we know anything else? So I also looked at this and I said, is there anything else that we could see that's a pattern? I see that Harry Liu is asking, can a digit be negative? Unfortunately not. If you are writing down numbers in an addition problem, you never get to write a negative digit. So unfortunately, you don't have that. So what else do we see? We see some patterns. I also saw somebody saw a pattern with the NU and the N. That's kind of neat, right? The same letter, the same letter. Oh, then obviously U is 0, right? Is that right? Does U definitely have to be 0? Well, not quite. Leo Yu is right. U is either 0 or 9. If it's 9, you could have done a 9 with a carry, right? If the U was 9 and there was a carry up here, it would also work. So let's write down something else that we also know. We also know that U is equal to 0 or 9. That's kind of useful. Something else we can look at. By the way, look at this N. How many N's are in this problem? Well, there aren't any other ones. Only here. These two spots are the only places that we have N's. Actually, what that means is that N can be anything. Do you see what I mean? If I had everything else figured out, and then I just say, all right, I've got one digit left, and that last digit is going to just go right there, and that'll be the N, it'll be okay. No matter what you put for the N, if everything else checked out, if everything else was legit, then, you know, N doesn't matter. So that's kind of nice. Let's not worry about the N. N equals not matter. I wonder if I have enough space. Oh, I do. Okay, N does not matter, all right? N stands for not matter. Okay, what else can we say? Now there was this hint about the IRO and the IVO. Poor N. Yes, Ray, you are a very empathetic, compassionate person. Poor N. IRO, IVO. Somebody said that means that R and V are the same. But that can't be. You're not allowed to do that. So you have to have them be different letters. If they're going to be different letters, the only way that they could be different is that there's a carry. So let's see. Where could the carry be? Could the carry be over here? What if the carry was over here? If the carry was over here, then it's okay for the R to be just less than the V, right? So it could be that the V is 1 more than the R. Is that okay? How many people think that I could have a carry here? By the way, this is an I, and that's a carry of a 1. Is it okay to have the 1 carry here so that my R just happens to be 1 less than V? No, because actually R is 1 less than C. You see, that's actually why I wrote that first. R is 1 less than C. And then R can't also be 1 less than V because they're all supposed to be different. And since all the letters are supposed to be different, that forces that it's actually that the carry is on the other side. This is actually how we're narrowing down the problem. Okay? So we're now finding out that we have no choice. So far, all the stuff I've written down here is no choice stuff. You see, either the carry makes V get a little bit bigger, meaning that V is 1 less than R, or the carry goes over here and R is 1 less than V. But it has to be where the pink thing is now. So based on that, I know that V plus 1 equals R. Okay, now what can we do? So, wow, it looks like I'm also in the chat. I didn't realize I could chat and type in the chat and also talk to you at the same time. Well, obviously that's what this other hand is doing. You see, I'm just typing in the chat at the same time. Okay, anyway, let's keep going. So I have that the R, the V, and the C, they're all in some order, and they kind of go like, they're consecutive digits. I prefer to write that in an order. So what I see here is that I have, what's the smallest? V is the smallest. It goes V, R, and C. And they're just in order, V, R, and then C, okay? Now, at this point, I guess it's guessing time. And the reason I say it's guessing time is there isn't much else that I don't know, there's not much else I saw that I could use here. So what would be good choices for V, R, and C? By the way, we already get to reduce a lot of choices simply because of the fact that I already forced these 3 to be right next to each other. Somebody suggest 3 consecutive numbers to be V, R, and C. And you know, if it's wrong, it doesn't matter. We're just going to try a few things. How come N does not matter? The reason N does not matter is because if everything else worked and I just changed N, it would still be fine. I see somebody suggest right away, 2, 3, 4. Let's see what happens, okay? And now it's the case analysis. So we've got the first case. VRC is 2, 3, 4. Case. VRC is equal to 2, 3, 4. I guess I maybe should write some parentheses around them, like ordered tuples. That's how we really write this in mathematics. Okay? But that's okay. So now let's remember what the problem was. It was rising plus virus equals corona. Now I have an advantage in that I can actually erase on this board. Let's erase. So let's erase all the V's and replace them with 2's. Oh, there's just one of them. Okay, so that's a 2. Let's replace the R's with 3's. There's 2 of those here. And let's replace the C with 4. Okay, hopefully I didn't make a mistake. As you know, if you've watched my live streams, I tend to make mistakes like this. I tend to make mistakes when I add, subtract, or all these kinds of things. Oh, there's an R in corona. Yes, you see, I made a mistake. That's a 3. Okay, and let's remember where there's a carry. We know that there needs to be a carry here and a carry there. There might be more carries also, okay? So in that case, this is telling me that somehow this S plus I had to be 13. So now we're doing trial and error, okay? We're now doing all kinds of trial and error. And if you're trying to make this thing work, it's like, how can I have things add up to 13? Remember, that's not a 1, that's an I. How do you make things add up to 13? I guess I could have 6 plus 7 is 13. Remember, I need different letters. I can have 5 and 8. I can have 6 and 7. Here's where we do trial and error. And, you know, let's try some. Okay, what do we want to try first? Let's try 6 and 7 since those are close. If I do 6 and 7, something interesting appears right away. If I do 6 and 7, if I put the 6 here, and if I put the 7 on the I, then look, the 7 plus the 3, that's going to carry over to here, and then I need things that add to 12, which is not convenient. Okay? Not that it's not convenient. I had 13. So that means if I did 6 and 7, I would have to do 7 on the I. I'll use a different color now. 7. Oh, no. That was 6 on the I. 6 on the I. And 7 on the S. And then this would be 7 on the S. Okay? Does this work? Could I make this work? Well, if I try to do this, now you can see what's going on. This part is okay. Does it really work? Wow, are we almost done? Let me see. I'm trying to stare through my writings here. It looks like the 6 plus 3 is 9, not 10. And that tells me I need to have a carry. So then that tells me that maybe I should have... Oh, wait. That's not a 0. These are O's. These are O's. So if those are O's... Let's try to fix this. Let's try to fix this. Remember, these are not zeros. These are O's. So if I look at what I drew here, I have 6 plus 3 is O. Okay, 7 plus 6 is 13, and that carried. And then 1 plus 6 plus 2, what's that? 7 plus 2 is 9. That's why somebody said O is 9, right? So if this was the case, then the O would be a 9. Are people with me here? We're trying to fill this thing in. The 6 plus, oh no, but the 6 plus 2 plus 1 didn't carry, so it didn't work. All right, that's how it broke. Thank you, everyone. This is bad. This part didn't carry. It doesn't work. Oh no! So that's not the answer. Okay, let's backtrack. So we can't do 7 plus 6 to be 13. And I'm going to undo, which is one of the things I get to do on this computer. Okay, so we did a lot of undoing. So 6, 7, 13 doesn't work. How about 5 and 8? Well, we also already know that if I want 5 plus 8, if I do the 8 here, 8 plus 3 will be 11, which will carry 1 over there, which will be annoying. I mean, annoying in the sense that it will break, because we'll have 5 plus 8 is 13, plus another one is 14. So it has to be, if I did 5 plus 8, it has to be 5 over here, 8 over here. And now does it work? 5 plus 2 plus 1, does that carry? No, that doesn't carry either. Actually, this is telling me something. So this is telling me that I'm going to have trouble making carrying because that number was too small. So actually, let's try a different set of V, R, and C. It looks like the 2, 3, 4 is very inconvenient. Like, how in the world do you go and make this guy carry? It's got to be bigger. So just to save some time, let me share with you what I ended up deciding to try. I decided to try 3, 4, and 5, which is actually just one more. Let's try 3, 4, and 5, okay? And I'll tell you a little bit of my instinct. Why I chose 3, 4, and 5 is because they were kind of in the middle. And in the middle, it was more convenient because I'd have space on the small end in case I needed to squish some numbers in there. And I'd have space on the high end also. Let's try 3, 4, and 5. I should say, when I do these problems, I just see them and then I try to crack them. And if I can crack them, then it turns out to be questions that we can talk about together. So, okay, let's try the next case. We didn't really finish that previous case. We could have done more of those things to check every possible case there. But just to save time, because this is a weekend live stream, let's try, oh gosh, what was it? Was it C or VRC? VRC being 3, 4, and 5. Now we have the rising virus corona. Remember that corona's O's are not zeros. And now let's replace the V with the 3. Let's replace all the R's with 4's. And let's replace the C with a 5. Remember that the O's are not zeros. Okay. Now what happens? Now when you look at this, let's go and try to see what we could do. We want to go and make 14, right? So how would we make 14? I guess we could do 7 plus 7? No, we can't have the same letter. How about 6 and 8? Let's try that. And this time if we want to try 6 and 8, oh, it still doesn't look good. Because if you put a 6 or an 8 there, it carries. Actually, what this is telling you is it's better to make a sum of 13 and have a carry. Okay, so let's try to make a sum of 13 and rely on a carry coming in from the previous one. So what could have a carry? I could, if I want 13, how do you make 13? I can't do 5 plus 8 because 5's taken. So let's try 6 plus 7. And, you know, how might we try to make the 6 and 7? Let's just try something, right? Let's suppose we did 7 here and 6 up here. Does this actually work? Let's see. So if I did this, what happens? So if I did the 7s over there and the 6 up there, I have 7 plus 4 would make 11. Remember, that's not a 0, that's an O. That would carry 1 over here, and then 6 plus 7 is 13 carried to make a 14. It would go here. 1 plus 7 plus 3. What's that? Ooh, this is interesting. 1 plus 7 plus 3 is 11. So this is telling me I can make these happen. So now look, we've got some carrying going on. 7 plus 4 is 11. 6 plus 7 is 13 plus 1 is 14. 7 plus 3 is 10 plus 1 is 11. Whoa! Now I have all of this side working. This is when I got excited. As I was doing this problem approximately 1 hour ago, I got very excited because I said, hey, look at that. All of this part's good. And now I don't really care what n is. Remember, n is sad. We don't care about n. But what should I choose for u now? It looks like I don't want any carrying. I don't want this stuff over here on the right to affect the thing on the left. So let's make u equal to 0, right? Because then that won't give any carries. So let's make u equal to 0. Oh, I'll do it this way. Oh, look, it's a 0 now. All right, so that's a 0. N doesn't matter. Worry about n last. And then this is when I got scared because I said the problem said you have to use every number once. Oh, S. S is also here. S is a 6. What numbers have I not used yet? I need to make sure I use every number once. I have a G, I have an A, and I have an N. So is there a 1? Yes, there's a 1. But there's no 2. Is there any 3? No. Yes, there's a 3, there's a 4, there's a 5, there's a 6, there's a 7. Oh, there's no 8. It looks like I can also have a 9. I have a 2, an 8, and a 9. So these are the 3 I get to play with. Can anyone tell me where to put the 2, the 8, and the 9? Aha! N equals 9. Let's make the n equal to the 9. And let's go and, I guess, 2 plus 6 is 8. Hooray! And that finishes the problem. So if I was to write the whole thing down in a tidy way, rising virus corona is 476,792 plus 37406. Added together is 514198. And that's the answer. The answer is, what is corona? Corona is 514198. This actually wasn't that bad. Originally, I thought this would be a time-wasting problem where I just have to guess and guess and guess and guess. But if you can see, the heart of it was to go and find out that there's some nice pattern, like the 3 consecutive digits. And once you lock those in, there's not much we can do with the other digits. Okay, so that was the fun math problem that I wanted to talk about today. And you know, the way I always run these weekend live streams is that we'll spend some time talking about a problem like this, and then we'll switch over to like a complete free-form Q&A. I do want to really make a very strong statement of appreciation for the people who organized the Mustang math tournament. You know how hard it is to come up with one of these problems? Really hard. I mean, like, how? You know, they had to make every letter be a different letter, and it had to even be something to do with something going on in the world right now, like coronavirus. That's amazing. I don't know how they have this much creativity, but, you know, hats off to them with my virtual hat. Okay, let's now talk about random Q&A. We're going to do that for the next about 20 minutes, which is the rest of this live stream. And the questions that I'd like to answer are the ones that just come from ranging all over in learning or in math, but not specific math problems. If you want to ask about specific math problems, please come on the actual daily Ask Math Anythings, which are from 4 o'clock to 5 o'clock p.m. Eastern Time every single weekday. All right, what kind of questions do we have here today? And here we're happy to answer all kinds of different questions that are not necessarily about a particular math problem. Oh, you guys are funny. Somebody wants me to solve a problem POH plus LOH equals Shen. I don't know, maybe one of you can do it. Angela Chang asks, did you get a haircut? No, I got many hairs cut. Okay, yes, I got a haircut. I got a haircut at home, thankfully. Be careful about going outside to get a haircut, because if you're thinking about, you know, how coronavirus spreads, unfortunately, if everyone needs to go to get a haircut, then pretty soon the haircutting place has coronavirus, and then everyone who goes there after that gets coronavirus, and it's pretty bad. Okay, yes, be safe, people. Other questions? Oh, somebody asked, what's the biggest infinity? See, the thing is, you can actually keep making bigger and bigger infinities. And maybe that would make sense to you, given that somehow in the numbers, you can kind of keep making bigger and bigger numbers. We talked about infinities in a live stream earlier this week, and inside that live stream, we even talked about the different kinds of infinity. But you can use a similar kind of idea there to show that you can always make another bigger infinity. Let's see. Oh, somebody asked, how many countries have you been to before the pandemic? I'm not entirely sure, but my guess is it's probably something like, probably on the order of about 20 to 30. That's my guess. And the reason is not because I have been to a number of places around the world, but the easiest way to go to lots and lots of countries is just to live in Europe. So I lived for almost 1 year in Cambridge, in England, because I was a master's degree student in Cambridge. It was great. It was actually very, very interesting to be learning in the same place where Isaac Newton had once walked. That's quite inspiring. Now, when I lived in England, it just so happened that there was a airline. It was a budget airline. It was called Ryanair. And this airline had some amazing deals. With this airline, you could fly from London, which is near Cambridge. You could fly from London to places in Europe for approximately $2 each way. $2 each way, plus tax. This was in 2004 to 2005. That's correct. You could fly from London to all kinds of different cities in Europe for $2, $2 plus tax. Now, $2, by the way, is not very much money when you're comparing to flights. Actually, if you're used to flying anything in the United States, $2 is how much you pay for like a quarter of a candy bar on the airplane. You know, I'm saying like, that's just like, come on, $2. They don't even give you snacks on the airplanes in the US anymore. You pay more than $2 for the snack. But Ryanair was $2 each way plus tax. Well, there was a catch. There was a catch. It was not that every flight was $2 each way. There were just some flights that were $2 each way. It was not poor quality. Actually, Ryanair, apparently they had one of the best safety records in the business at that time. And it was safe. It was fine. It was clean. It was great. The issue is that not every flight was $2. So you see, a lot of people would maybe have a cheap flight going out, but when they came back after they were done, they would maybe have to pay the regular price. And also, it wasn't every city that had the $2. But see, I was an American. So I was an American who had never been in Europe before. And so I actually didn't really care where I went. I just thought it would be interesting to go and explore Europe. So the way I traveled was to just go and say, where can we go for $2? You see, most business people have some constraints. They have a particular city they need to go to on a particular date. But you see, I was a student, and this was during the break. I had no constraint on the date and no constraint on the city. So it was just, where in the world can I go for $2 today? Let's do that. Just to put things in perspective, the bus ticket from Cambridge to the airport was about $10. So anyway, that's what I did. Because I did that, I was able to go and see a lot of different cities. I will strongly recommend studying abroad to anyone who has the opportunity to do so. And if you ever find yourself in a situation where you have a break and you can fly places for $2 each way plus tax, I strongly recommend doing it. Okay, more questions. What else can we have here? Haha, Harry Liu, you are so funny. You've learned my tricks. Are you standing on paper? Yes. How did you know? That's how I got taller, but that's what I told you guys before. But not only am I standing on paper, there's another part of the trick. This is what you usually put a plant on. So the actual equipment here in the studio is the plant stand, you know, like the thing that you would put your plant on, and a ream of paper. And between the two of these, you have a great stool. You might be asking, why don't I just have my assistant move the camera? Well, that would be nice, except that my assistant is not here right now. And so I needed to have a setup where we would be able to switch anything that we wanted, you know, even if there was nobody here helping. Yes, so this is actually what we do. And I'm just sharing this with you because this also shows, you know, if you want to create things, you don't always have to create things by buying really fancy stuff. You can create things by being creative and saying, well, we don't have a plant anymore, so I'll be the plant. All right, what else do we have here? So David has asked, how does COVID affect global warming? That's a deep question. So there are lots of different ways that global warming could be affected. I mean, one of these ways is that maybe people are not burning as much carbon. And maybe that's going to slow down the rate of global warming by a little bit. Maybe. But at the same time, there are also other things that might come into effect. We also don't, for example, know how much of the carbon dioxide will be sucked up by crops. So I actually am not entirely sure how to think through what are the different effects, right? I will say one thing that's happening, though, is that there is less pollution, right? So pollution and global warming are slightly different things. Global warming can be affected by lots of different factors, but pollution is generally affected by human beings creating pollution. And so fortunately now we have less pollution. And actually, I've also heard that lots of people are starting to find out that you can bicycle places and finding other ways to get around that maybe are a lot friendlier to the pollution. All right. What other questions do we have? I'm going to pull up this display here where I can see some of the questions that might have come from other people on our team. Oh, wow. Hi, Yan Chang. How to make a very slow rocket. Oh, you need to ask a rocket scientist for that. But fortunately, where I went to college was close to a place where lots of rocket scientists worked. Here's the important thing to know if you're trying to build a rocket. You might say, come on, why is everyone talking about rocket scientists? Like, what's the big deal? Why is it so hard to build a rocket? Well, here's the reason. Guess what you need in order to make a rocket go? What does a rocket need to go? How does a rocket go? It needs to have fuel, obviously. The rocket needs to have fuel. It needs to have thrust. It needs to have fuel. But now, as it's burning the fuel, it needs to make sure it has enough fuel to burn. So here's an easy way to build a rocket, okay? Very easy way. You just get a huge barrel of oil, you drill a hole in the bottom, and you light it on fire. Please do not try this at home. Even though the price of oil was negative, this could cause a significant negative thing to happen to your house. But anyway, it's just like, if you go and get this barrel of oil, very dangerous, it will go and make some explosive stuff, and it might not go very far. Maybe it only goes up a foot. And you say, clearly, we just need to put more oil on that rocket. So you get 2 barrels of oil, and you stack them on top of each other. But now this doesn't work, because now the first barrel of oil needs to lift the second barrel of oil. What I'm trying to show you is that there's something called the rocket equation. And the difficulty with a rocket is that you eventually need to also be able to lift the fuel that you need in order to lift you. And so this is why building a rocket is not easy. Now, if you wanted to build a rocket that moves very slowly, your difficulty is that even if you just kept stacking more fuel on top, you'll have a problem because your rocket will not be able to escape the Earth. I don't think the rocket counts if it just kind of levitates for a little bit of time very slowly, runs out of fuel, and then comes right back down. So this is why it's not super easy to go and build a super slow rocket, at least not until we have some of those Star Wars type anti-gravity things, if that's even possible. More questions. Do I have any number theory tips, asks Alan Wang. Yes, I do. Oh, actually, I should probably put my cup there's a place where it's harder for you to see. Okay, great. Do I have any number theory tips? Yes. I would say that the number theory is the subject where it can seem like there's a lot of stuff to memorize because there's all these different theorems. For me, I didn't really understand number theory until I started playing around with multiplying numbers, actual normal small numbers by each other, and looking at remainders. Actually, in the class that we run, we have an online course on number theory. All of those theorems were proved by me just thinking, how would I try to explain that to myself? And by doing that, I was able to learn number theory even better. So what I encourage to you is if you're trying to learn number theory and there's some fact that someone tells you, just go and try to see if you can find a pattern. You see, you might say, I thought number theory is supposed to be about proofs. But if you find patterns, you start to explain the patterns. And the beautiful thing about number theory is that there are a lot of patterns. And once you see a pattern, you can try to prove that the pattern works. And then once you've got that, that's a tool. And you can use that tool to prove even more sophisticated patterns. There's actually an entire summer program. There's 2 of them. They're very closely related. One is called ROSS, and one is called PROMISE. ROSS is R-O-S-S, and PROMISE is P-R-O-M-Y-S. And these are 2 wonderful programs for high school students where they learn number theory. I'm not entirely sure how easy it is to do those programs this year, just because of the fact that people can't go and live amongst each other. But the way that these programs were designed was that people would actually go and think about the theorems that were under number theory, and they would fight with them, finding patterns and explaining them. And that's actually, in my opinion, one of the best ways to learn it. If you're in middle school, what you can do is you can start by doing number theory problems from Math Counts or AMC, and that will teach you a lot of these patterns. Okay, more questions. Evie Shen, how tall are you in feet? Thanks. 2 feet. If you want like a real answer, I think I'm like 5.5 feet. But yes, if I stand on this, then I happen to be maybe 5 and 5.8-ish or so. Okay, next question. Ooh, Shireen Zhang has 3 feet. Bangle Wei asked, is it possible Star Trek or Star Wars is real? You know, I think that some of the ideas inside Star Wars might be a bit far-fetched. I'm not entirely sure that there are such things as Jedi in the real world. I think I just don't understand enough of the Jedi universe, but to me, the notion of Jedi and the Force don't quite seem to be based on physics. Sorry to burst anyone's bubble, but somehow to me that might not quite be right. Someone else also said, there's no sound in space, so when the blasters are whizzing by, you shouldn't be able to hear it go, shoo, right? It wouldn't quite work. On the other hand, there might be some other things that might be okay. Maybe you could build a big laser. That's actually quite possible. You quite possibly could build a big laser. But the practicalities of building a laser that can blow up a planet, now that would have to be a pretty powerful laser. So I'm not entirely sure how easy it is to do some of those things. At the same time, I do think that Star Wars and Star Trek do serve a very important inspirational purpose. I mean, for me, when I was growing up, even the notion that, gee, stars, I wonder if it would be possible someday to go a long distance. It's kind of cool. I think that we as humans need something like this. If you think about what Elon Musk is doing, right? He's trying to get people on Mars. I think that it is very important for people to always have something that we're reaching towards that we haven't achieved yet. And so I do think that space, is the final frontier. And I personally do think it's very, very interesting to think about space. I just right now happen to be focused on some very earthbound problems like the COVID-19. Maybe some other time in the future, who knows? Maybe in 10 or 20 years, I'll have the pleasure of thinking about something else that's out there. Somebody seems to want to know what stylus do I have. I just have the stylus that came with the computer. I specifically, when I knew I was going around the world giving all these talks, I actually bought a tablet computer so that I could just go and have my blackboard with me. Because as I was going to different schools all around the world, sometimes the schools would have me give the talk in the big auditorium. And then when they said, all right, here, go plug your computer in the screen. I said, but I'm a mathematician. I don't plug my talk into the screen. Do you have a blackboard? I'd love to draw stuff. And then those people would say, we don't really have a giant blackboard for the auditorium. And so that's when I realized, aha, you can actually go and use a tablet computer and project it, and then you can have a blackboard. So what usually happened is I'd go to these cities, go to these places, and people would say, all right, can you plug in and test your slides? And I'd say, well, I actually don't have any slides. I just need to plug this thing in, and then we'll just have a chalkboard talk with this blackboard. Okay, possibly after the pandemic ends. Indeed, I certainly hope that I'll be able to move around outside again. One thing I miss is being able to actually see you guys in person. What else do we have here? Skylar Schreier also made a comment about the Star Wars. Explosions need oxygen. That's a good point. Actually, if you wanted to have some exploding starship with this fire, the fireball, it probably would need oxygen. Now the question is whether there's enough oxygen inside the thing to provide fire, to provide something for the fire to burn. But in reality, actually, in space it's very dangerous. In space, you don't need a huge explosion to kill all the astronauts. Actually, you just need to have a micro meteorite to hit and penetrate the, just like a little thing popping through, like that helicopter flying overhead. Something popping through, making a hole inside your wall. And if you got that, unfortunately, it's curtains. I mean, there will be no oxygen in the whole capsule soon. So it's just that somehow I think that it was more exciting for Star Wars for there to be explosions as well. What else do we have? Oh, Gabriel Song asked, did you get a scholarship at Cambridge? I actually did. That's why I went to Cambridge. I applied for some funding. It was by the Winston Churchill Foundation. That's a United States organization. And what they do is they provide a way for some American students to go and study for a year in Cambridge as a cultural exchange. So, I mean, in general, I do think that it does make sense to try to get as much education as you can. And if there's any way that you can do it with a reduced cost, it's also good. All right. Volume too low. Please turn higher. Well, there are two ways to raise the volume. The other way is to move the microphone. Let's see if that helped. Okay, I'm not sure if this actually solved the problem, but we moved the microphone a little bit closer. And the reason why I did this, by the way, is because of math. The microphone used to be that way, and now it's this way. It just moved across. I just made a 45, 45, 90 degree triangle. So actually the microphone is now square root 2 times closer, or the distance is 1 over root 2. And the way that power goes by what's called an inverse square law. So what that means is that there should now be twice as much power going into the microphone as there was before. This is also why if you ever find yourself like on a field and you're supposed to go from one end to the other end, go across the diagonal and you save a factor of root 2. Okay, what else do we have here? Oh yeah, and also, by the way, what you just saw with the microphone moving up and down, that's the actual reason why today's live stream started a little bit late. It was because we were just filming something for Novid right before this, and we had the microphone thing a little bit too high, and you could see the microphone sticking out over there, so I had to adjust it. Okay. Oh, neat. Okay. Brian YT has asked, Po-Shen Loh, can you please make a coding video or talk about some coding? Well, so if I wanted to do a coding video, it's not as interesting. It's really best for you to do some coding yourself. The best way to do coding and to learn how to code is to go and get examples of working code and then make little changes. That is how I learned everything that there was to learn about programming. And by taking examples of working code and adjusting them, you will soon start to understand how all the different parts of the code fit together. And I know that there are courses on coding which will say first learn this, then learn this, then learn this. But I actually learned coding when I was like in first grade or something, because there was a magazine that my parents subscribed to. And this was a long time ago. The magazine actually had code in BASIC. Actually, there was always 2 pages, not 4. There were 2 pages of the magazine which had the source code of some basic program. And I would always read it. And when I read it, I sort of eventually figured out, oh, that's what this means, because it looks sort of like English. And if you just read, like you just read this code for a while, every single week or every single month, after a while you say, maybe I can try writing something like that. Or if you do website design, if you go and find a working website and make some changes, you soon learn what everything does. So I actually recommend that. If you go that way, you'll learn how to code pretty fast. And by the way, that's also how you learned your first language in real life. You didn't learn your first language in real life by somebody saying, let me give you a course in this language. Because if you don't know any language yet, how in the world do you start that course? You just go and you experiment. You see some examples of people communicating, you adjust some words, and you find out that they still understand you, right? And then you adjust the words the wrong way, and you find out that someone gets mad at you. And you say, I probably shouldn't do that again. And so if you do the same thing with computer programming, it also works. I see that Michael Sun has asked a question. Why is Chapter 5 number theory so hard? So yes, you're talking about our online course. Well, number 5, number theory is our module which we put at the 5th position, not the last position, the 5th position, because it's one that is best to do when you have a lot of the background built from the other modules. It's hard because number theory is actually a hard subject. But what we try to do is if you explain everything slowly with lots of examples, hopefully hard things can become not so hard. And ultimately, number theory is actually something that most people don't learn ever in their life. But the hope is, by looking at it the right way, even if you're in middle school or elementary school and you stick with it, you'll actually be able to learn it. Okay, what other questions do we have? Can you summon a monster? It didn't work. I guess the answer is no. Okay, other questions. Raymond Lee, do you think that stopping time is possible? Yes, when you're editing videos. But in real life, I don't think so. Okay, other questions. I guess some of you were expecting that maybe this would actually summon the monster, but unfortunately, I'm not capable of doing that. Okay. Huh. Kyle Hongran He has asked, how long have you been a professor? So I've just finished my 10.5 year. What a strange way of saying that. Okay, so I've done 10.5 years. I came to Carnegie Mellon University in 2010 in January. So I finished my 10th full year in December of 2019. Yeah, December 2019, and this happens to be the next semester. So yeah, I will say it's been a very interesting journey, and I think that the most interesting part of it for me was the chance to work with some really, really interesting students. Who knows? Maybe some of you will come and join us in a few years. Actually, if you ever do decide to join Carnegie Mellon University as a student in the future, please do say hello. Okay, let's see. What else do we have here? We are over time, so let's just finish one last question here. Okay, this one, a follow-up question, and that will be the last one we talk about today. Brian Whitey, Po-Shen Loh, thanks for your answer. Can you please tell me where you get working code? Please. Here's how. You should start with some things that are simpler to do. The people who suggested website design, that's not a bad example. You know, go and find an example of a working website, not like Wix, but like some HTML thing. And you go and look at that and you edit it a little bit, and then you can see that it works. There might be some places that you can host this HTML, and you can see it. Other things you can do are, you know, nowadays I'm playing a lot with this like Android development on your smartphone or iPhone development on the Apple phones. You can actually find a lot of example programs, and they will give you like a whole thing that you download, like install this thing, download this thing, and install it, and then make it run. That can be a bit complicated if you're starting from scratch. Another way that I learned a lot of coding was by playing with these computer programming contests. And now that's a lot more focused, which is actually easier at the beginning, because all you have to do is write like one function, just write one thing that does a calculation. And then how you find working code, you look at the examples of programs that worked that other people wrote before. Someone said, is it like USACO, USA Computing Olympiad? Yes, that's how I got into a lot of this stuff. And so you could look at working code by just looking at what other people wrote. You know, it's like, here's a problem, you thought about it, you tried writing something, or you didn't try, and you just look at some example of what did it. And I think with Python, it's actually quite simple nowadays to look at a Python program. The hardest part is just installing Python in the first place. But in general, what you need to do is you just need to go and find all of these different, find whatever language you want to play with, find some simple thing to start with. The first one is often to say something like, hello world. But as you start to get used to this, then you can actually figure all of these things out. All right. Well, unfortunately, our weekend sessions typically end at 8:45 Eastern Time, so we are unfortunately over time. And I guess I won't be able to continue discussing these questions. But I think that what we need to do is just to have more sessions. So we won't have a session tomorrow. Instead, there will be a session again on Monday, continuing the Ask Math Anythings. If you enjoyed what we're doing, please do come back. And you might actually get a joke. We'll save that for the next time. How does that sound? So we'll have the session at 4 p.m. Eastern Time on Monday. Have a very safe and happy Sunday, all of you, whether it's the Sunday already for you right now, since you're in Australia or New Zealand, or whether Sunday is coming up on the horizon. Good night.